Though we know who we are, yet we know not what we may be. So maybe I'm the one, or maybe I'm crazy. I'm from.
Welcome back to your No Malarkey Guide to Machine Learning. My name is Kalu. Kalu, congratulations, because in our last video we were able to get the coefficient for our first independent variable for our B1, and that was 80.67. That means for every 1 unit increase in square feet, we expect the price of our prediction, the price of our home, to go up by $80.67. That is great. Now we want to do the exact same thing that we did with our correlation, our method for finding correlation, and our method for finding the standard deviation, which is write all of these calculations and we want to abstract it away into a function. In other words, all these calculations we did in our last video in order to find B1, the coefficient of our first independent variable, we want to put all these calculations and abstract away these details, hide these details into a function. That way, when we call this function, it can just magically spit out this number. When we call this function and give it the right information, it will magically spit out what our coefficient should be. So why don't we go ahead and do this? We should be very used to this formula, this first do it, then abstract it, then do it, then abstract it. This is the third time we're doing it, so why don't we get started? So I'm gonna go ahead, and we have the same window we've been working in for all of our videos. So we still have our get correlation function that we created. We should still have our get correlation function, in our get STD function, in our area, in our garage area, in our price. We should have all of these still initialized inside of our Python interpreter. If you don't, then first let's go ahead and, if you don't have this get correlation, then we need to recreate this. Why don't we create it into something called get core? And we're just gonna do this like this. And the reason we need this get correlation method is because we cannot use this np.correlation coefficient, because if we use this, let's say area price, it gives it out a list. And we don't need a list, we need an integer. So we need the first row of the list and then the second item in the first row. Sorry, the first row of the list and then the second item in the first row. And that is the number. So we need this. So why don't we just go ahead and, in case you don't have this get correlation method, let's do a get core, right? And it takes both an X and a Y, and it just simply returns, let's go ahead and copy this. First, let's do import np numpy as np, and it just returns this right here. It just returns np.correlation coefficient of the X, the Y, and it gives us the number, not the list. So we need to add this to get the first row and then the second list, the second item in that row. So that is our get correlation. So we give it an area and a price, and now it gets us a number instead of a list. Great. So we just needed to do that for the next function we're going to write. So let's go back to writing this in a function. So we are going to call this get regression coefficient. And that is going to take an x1, an x2, and a y. So instead of x1 observations, instead of x2 observations, and instead of dependent variable observations. So 1, 2, 3, 4. So the first thing, let's deal with this right side of the equation first. And this right side of the equation is just the standard deviation for y divided by the standard deviation for our x1, our first independent variable. So why don't we go ahead and say right side of the equation equals, and again we can use this built-in, we can either use our get std function that we created or the built-in method that pandas series comes with. So let's use the built-in method. So x1 or y.std, and we need to call this method divided by x1.std, and that's going to give us this right side of our equation. Now let's work on the left side of our equation. Let's work on just the numerator of the left side of our equation. To do this, we need to get the correlation between our y and our x1 and subtract it by the correlation between the products of the correlation between our y and x2 and in the correlation between our x1 and x2. That's a lot of words. We did this in the last video, so I'm not going to re-explain it. Let's just go ahead and get this. So first we need the correlation between our x1 and between our y and x1, and we can use this get core method or function we just created, and we're gonna give it our x1 and our y. Let's just go ahead and write. Well, the order doesn't matter, but let's just go ahead and write y and x1. So now we need to get the correlation between our independent variable, or y, and our x2. So y x2 correlation equals get core y x2. Now we need to get, oh no, I accidentally pressed enter too many times, so I'm going to redo this again. I pressed enter too many times, so we're going to redo this again. Now we need to get the correlation between our x1 and our x2. So x1, x2 correlation, and we can get that by using this method, x1, x2. Now we have it. So we have all of these correlations. So let's work on getting that numerator. So the numerator equals the correlation between your y and x1 minus the correlation between your y and x2 times the correlation between your x1 and x2. And so we're going to get that, and that is the numerator. Now let's get the denominator of the left side of our equation, which is 1 minus, and we're going to have the correlation again of our x1 and x2, except we're going to square it. And so that is going to give us our denominator. So now let's get the left side of our equation, which is again just this numerator divided by this denominator. And we again got it earlier, this numerator divided by this denominator. So that is the left side of our equation. So now we can actually get the regression coefficient, and that is going to be equal to the left side of our equation, this part, times the right side of our equation, this part that we got earlier over here. And now let's go ahead and return that regression coefficient, and let's see if this works. So get regression coefficient, and now we need to pass it in x1. And our x1, remember our first independent variable is area, so let's pass it in x2. Our second independent variable is the garage area, and now let's pass it our y. Our y is the set of observations of our prices. So let's pass it all these arguments that it needs. Uh-oh, no, I made a mistake here. Instead of right side, I did right. So I'm gonna go ahead and write all these things again. So define it. Once I define it, get the right side. Get correlation between, oh no, get right, let's do this again. Get right side. Get correlation between y and x1, get correlation between y and x2, get correlation between x1 and x2. Let's now get the numerator. Let's get the denominator. Let's get the left side of the equation. And this is where I messed up last time. Let's get the regression. So this is where I messed up last time. It's right side. Okay, now let's return this regression. Return regression coefficient. Good, now let's go ahead and use this regression coefficient. And again, we pass it our first independent variable, our second independent variable, and our dependent variable. And there it is. It spits out this coefficient, regression coefficient for our first independent variable. And if you look, this 80.67 is the exact same thing we got whenever we did it manually over here. We did it manually someplace over here. This is when we did it manually earlier in the last video. So congratulations, guys. We had a little bit of mistakes, but hopefully you were still able to follow on. This is the function we created that abstracts away all the details we did in the last video. Now we just have to use this simple regression to get the coefficient. So if you see, the coefficient for the second one is just the exact same thing, except now it's x2, and this one is x1. So in here, it's x2 instead of x1. So we can do the exact same thing. So let's say let's call this our x1, our b1 equals this. To get our b2, we just need to do the exact same thing, except switch around. Now here, our area, our garage area and area, we just switch this around, and that is our b2. So we have gotten our two coefficients. We've gotten our coefficient for this and our coefficient for our first independent variable, which again, don't forget, is our ground area. And we've got the coefficient for our second independent variable, which is our garage area. So we've done a lot. Next, we need to figure out this right here, which is our y-intercepts. And to get the y-intercept, we just need to follow this simple formula right here, which we're going to do in the next video. So congratulations, guys. You keep on doing excellent. I'll see you guys in the next video. Peace. And don't forget, I almost forgot, if you like this video, share with your friends, like, subscribe. If you're African, you got to share with at least 200 of your friends, okay? So thanks again for watching. See you guys at the next video, where we go ahead and try to calculate this y-intercept, or the A as we also call it. See you guys.
Financial freedom, my only hope.